There it is. I want to get y1. You say y1 comes from vars. Vars is the VARS right here. If I click vars and go to y variables, some of you guys know to use alpha zoom is another way to get after that, y1. If you want to use alpha zoom and work around that, that's fine. But y vars, vars, y vars, and then function, you hit enter and you get all the options like y1, y2, y3, whatever. So, and to enter something into y1, you just put parentheses after it. So this literally takes, and it puts -2 plus x into, it's like putting -2 plus h. It's just what we did by hand, but it's doing it for you. Okay, so it shoved it in there for you. And then, so as I go over, that's 2 plus x. You can't type h, it won't work on a TI 84, so don't try it. You want to do y1 and then put -2 in it, and that means go to y bars, put -2 in parentheses after it. You need parentheses around your numerator. You got to have a big set of parentheses around your numerator or it will miscalculate. So if you look at mine, there's an extra set of parentheses going on in there. So let me show you. Right after the -2, you got to insert parentheses. Okay, I'm going to give you a second to enter those in. Do it to it. You're going to like it. Because you're going to experiment for me. Okay. Divided by x. So all I did is I'm writing the same expression you see here, but instead of f, it's y1. Instead of -2 plus h, it's -2 plus x. And instead of dividing by h, I'm dividing by x. This allows me to take h towards 0. I'm going to put in really, really tiny h's that get closer to 0 manually. It's really fun to do that. Danny, you got to put that thing away. Put it away. Chap snatty no more. Okay. That's the full expression. Can I clarify any of those entries? We're going to go table set. Second window. Second window is table set. Go second window. Come on, come on, come on. Second window. Second window. If you come in and ask me for help on this, and I'm seeing multiple of you who are not doing it, you aren't going to get much from me. I want you to go to ask on your independent. We're going to put in x's, which remember stand for h at this moment. What we're dealing with right now is I can't type h into my computer. So I've got x equals h. So what I'm going to do is I'm going to input h's of my choice. The goal is I want to shrink h down to almost 0. But not really make it 0 because I can't. That'd be divided by 0. That's a no-no. So here it goes. So go ask on your independent, and when you go to table now, second table, check this out. Put in what you want. Put in really small numbers. Point.
How do you get to show only y2?
You have to turn off y1 and turn on y2. Crazy, huh? So let me go up. My y1 is now not highlighted. Equal sign is off. y2 is highlighted. Okay? And then when you go to table, if it's highlighted, it'll show up in the table. So now you put 0, 1. I put .0001.
Wait, so does it matter what you have on your table start thing?
No, as long as you put independent ask. All I'm doing is now I can put in any x I want.
So I can just be done with that?
Yep. So as soon as you do second table set and your independence on ask, that means any x you want to put in, it'll take it. It's a handy little, like I don't want to mess around with having that pick x's. I'll pick my own x's. Put in really small values of h, and look what it heads toward. Look what we get.
Okay, I put in like a big one that said 0.
Uh-oh, yours is too small. Try something like .0001.
What if mine has an error when I
You might have a typo in
Okay,
your
now
y2.
it's time. I'll
like
Your, depending on how much, now Bryce, you were just overshooting it. Do like 5 zeros or something like
6.
Okay, you went that far. Your calculator is an approximator. It'll get to 10 because it's just, that's what it does. The other things that can happen in Y2 is how you typed it. So I'm going to show this one more time for those who want to see it. So see if you got the parentheses around the top is really important.
Oh.
Y1 with negative 2 plus x. So we got the function in there. This is the limit function. We're forcing h towards 0 but not letting it be 0.
Oh, is it negative 2 plus x?
Yeah.
And minus 2.
Yes, it doesn't like minuses, it likes negatives. Is that fun? So there we go. And then as you take a look at that table of values, it starts looking pretty good. Okay?
I lost my
Table. And then you get 10. So the idea is we get it mathematically, algebraically. This is called numerically evaluating a limit. That is the numerical route to evaluating a limit. That's today's lesson.